Hello, ladies and gentlemen. Today we're talking about how are the lengths of various segments in a circle used in problem solving. So we've covered a couple of rules here. First, the rule we covered was if a tangent line intersects a circle, then the radius becomes perpendicular to it. So we can make a right triangle, and solve it that way. We also talked about if two tangent lines intersect a circle, that they form an ice cream cone, and that those two tangent lines are equal. Today, we're going to talk about if two chords intersect in a circle, then the product of the measures of the segments of the chords are equal. So basically, what it's saying is that, all right, so it's saying that this part right here, and again, please write where I write, is going to be part of this, is going to be, this part is going to be multiplied against the second part of the segment. So this right here is going to be multiplied together. You're going to multiply both parts times each other. And then you have this part over here. And again, excuse my writing, your box will be a little bit closer. But anyway, you have that part, those two parts there. So basically what it's saying is it looks like a railroad crossing. I know some of you may be familiar with this. So it looks like a railroad crossing sign. Okay, so basically that means that two chords are split up into four parts. So you have part times part equals part times part. Now again, the parts you want to keep in, as I tell your classmates in class, or I was saying in class, is you want to follow whatever number or measurement you have on here. You want to follow the line through. You see how I've traced it? That's what you want to do whenever you have a chord. And that way you're sure to get the values that are supposed to be together. All right, so let's do some, and so anyway, that's basically saying that WC, last part, is times CX. So you see WC, and then CX. So that's C, and that's X. All right, equals YC, which this time I'll use boxes. So you got YC times, and then I guess I'll just do check marks by CZ. Okay, so basically we're going to do some problems like that to help reinforce these concepts. So basically saying part times part equals part times part. All right, so let's do an example. So here we're going to be told that this part right here is X. This part right here is 15. This is 12. And this is 9X down here. So what we want to do is, remember what I was saying, so let's take 15. If I look at 15 and I trace that chord, it's going to encounter 12. So I'm going to say 15 times 12. Okay, equals the other two parts, which are left. All we have left is 9X times X. All right, so 15 times 12 is 180. And then 9X times X is 9X squared. All right, so now here, all we're going to do is just solve it simply like we normally would. We would divide by 9 on both sides and get 20 equals X squared. Then we want to find the square root, so we find the square root of both sides, and that gives us 4.5 equals X. The main issue students have with this concept is not getting the right numbers. They'll try to say X and 12 or X and 15 and 12 and 9X. Again, when you find your number or your variable, trace or follow the chord from one end of the circle to the other end, and the other number that you encounter is going to be the number that goes with that first number. Okay, so let's try it with another problem. So it says find A, B, and D, E. Now you want to make sure you pay attention. On the first question, it said find X. Here, when I give you the values, you're not going to just find X. We're going to find out what those those chords, what the measurement of those chords are. So we got X plus 10 here and 6 here. So again, I'm going to this time pick X plus 3. So x plus 13. So again, if I trace it, x plus 3, x plus 13, encounter is 5. So I'm going to say 5 times x plus 13 equals the other one, which was 6 times x plus 10. Okay, now you could have said x plus 10 times 6 and gotten it, but again, you don't have to do it that way. Okay, sorry, I'm just going to try to make it a little neater here so it's a little easier to read. So we're going to distribute the 5 inside here and get 5x plus 65, because 5 times 13 is 65. And over here we got 6x plus 60. All right. Because I want a positive x, what I'm going to do is I'm going to move my 5x first by using the inverse and making it, instead of positive 5x, it's going to be negative 5x. And that's going to give me x plus 60. Then I'm going to subtract 60 from both sides and get 5 equals x. All right? So remember, that wasn't what the question asked. It didn't ask us to find x. It asked us to find what a, b, and d, e are. So a, b, we go back to that. That segment was x plus 10 plus 6. So that's both parts. We're not multiplying here, we're just adding them. So we're going to plug in 5 and get 5 plus 10 plus 6, and that's going to equal 21. All right? The other segment we were asked to find was DE. So that was x plus 13 plus 15. Okay, so again, we plug in and put 5 plus 13 plus 15, and that's going to equal 23. All right? So that's basically how we're going to deal with 4.2 in terms of using chords. So remember, when the chords cross or intersect inside the circle, that the measures of those segments, or the parts of those chords, are multiplied and are equal to each other. Okay? So your next activity will be to actually practice this rule and concept, and that would be 4.2 practice. So please stay tuned to that and complete that as soon as possible using these notes. Thank you and have a nice day.